This conference will now be recorded.
Okay, guys, so today we are going to start with an advanced training. We are going to talk about the topics, right? The main topics what we are going to cover in this next 2 weeks. The whole next 2 weeks is going to be all about GitOps and followed by a 1 week project. That is what we are going to do next. And today I will talk about a brief introduction about what is GitOps and why that is important inside a company. And then we will also talk about what are the difference between operations team and the developers. And this GitOps is probably an attempt to make the work of operations kind of much similar to the one of developers. But just like how the developer manage the code, DevOps engineers would manage the operations. And that is the kind of concept, but that's not just the only thing. We will be talking more about it, but yeah, this is going to be one very important training that we are going to start today. And we will be covering different tool. Argo cd is the GitOps tool. And then we are going to talk about customize is used for configuration management. And then we will also talk about crossplane, which is nothing but it will be used for the infrastructure as code. So I will be explaining each of them one by one what they means. So today we will talk about some brief introduction about GitOps, what is GitOps and why it is relevant and why you should start adopting GitOps. So those are the things that we will talk about today. So let's get started. I will. Yeah. So I'll be sharing this document with you. In this document, I would be adding day-to-day topics what we are going to cover, and I'm going to share this document with you on your Gmail ID on the Google Drive. So today, we are going to talk about what is the main difference between the developers and operations, and maybe it's not development and operations. Today I'm going to talk about what is the difference between developers and DevOps. And in order to give you an overview, first I will talk about what is the difference between developers and operation, and then why operation team should work using Git, right? Using Git, they should be working, and what is the significance of working using Git. And then we will talk about what is GitOps, and then we will talk about install ArgoCD and how we can use ArgoCD, what is ArgoCD, and then how we can use ArgoCD to implement the GitOps practices inside your company. And then we will, ArgoCD has some UI that we will see, some technical details we will get into about the Argo series. So first of all, let's talk about who is a developer and who is a DevOps engineer, and what exactly do they do, right? And I mean, this definition will vary every year or maybe every month, right? Because the way how the companies are working are changing very faster than how it used to be. So you cannot clearly define the difference between dev and ops. It changes day by day. So and let's say let's talk about today. We are going to talk about in 2022 what a developer should be doing and what DevOps or what operation engineer should be doing. All right, so let's get started. So inside a company, there are different team. You already know that there is developers, there is operation team, and then there is QA engineers who is responsible for doing some type of development. Even the QA engineers, whatever they do, what they do is a kind of development. They are developing some test cases or test programs that will actually automatically test the main programs. That's what QA engineers do. So You can call them also as a developer because they also do the similar job what developers do. And then basically the development team, they always do a lot of coding based on the situation, based on the new feature that they need to implement inside the software. They will take the software code and they will make all the necessary code changes, and then they will add their code changes into some Git repository. Assume the company has a common storage, something like a Git repository, and that is where all developer would make the code change and push their code into. So that's what they do. There are a bunch of developers, and together they do the development, and from their laptop they will continuously modify the code and put that code inside a Git repository or some common storage that the team uses. And and I told you, then they do the actual development of the software, and similarly there would be people who would be dealing with QA development, right? What they do is they will be writing some code, right? They will also be writing some code, and but the code whatever they are writing is used for testing the actual developer's code. You agree with me, right? That's what they do. Assume your QA team who is using Selenium as the QA automation tool. So after they finish their, they will be writing some script that Selenium will be capable to execute. And that is exactly what they do. So they will be writing some script, and then those scripts also they will put inside a Git repository. And then once these things has come into a Git repository, then probably those script can be downloaded by Selenium, and Selenium can actually execute those scripts. You already know that. And then assume you have a team of operations, and what they do, they takes care of the surveys, they takes care of the release, they takes care of the uh, configuration changes, right? All those things. It is the operation team who takes care of such kind of things. And what if they also work on the Git, whatever operation change that they need to do? Maybe they want to create a deployment, they want to release the latest version of the software to the production, or maybe they want to make some changes in the configurations of the software. And they do a lot of things. They want to monitor your software, different applications that are running in production, they need to be monitored. And then a lot of work, right? Operation team generally does the more complicated jobs inside a company, scaling up the machine, scaling down the machine, then working with your cloud provider and creating more machines in order to run your application, or then deleting the machine that are not needed anymore. So all these things are done by the operations team. And assume they also have this capability to write what they want to do as code and put that inside Git, right? I mean, you want to scale more machines in the cloud, you want to add more machines in the cloud, then write it down inside a file and put it inside Git. You want to increase the number of containers for the given code from an application, then increase the number of containers to this number, and then put that inside the Git repository. And then you want to change something, you want to add a new environmental variable inside a given container, then you would add that environmental variable in a file and then push that inside Git. So whatever infrastructure change, or whatever, other than development, whatever infrastructure modification that you need in your company, assume all those changes are put together inside a Git repository. And this is what humans do inside your company. Assume. And this is the way how teams should be working today in this year 2022. Maybe, I mean, it can change. It can probably get more and more advanced, but this is the approach that we should always try to follow. And it's true, most of the companies are not following it. I mean, it's absolutely fine. There are various approaches in working, how you do the job and stuff like that. I mean, it's not important that this is what companies should be doing. There are many companies who is doing very good in a different way. That's absolutely fine. But as per the practices that are getting evolved nowadays. This is going to be the approach that people work. Whatever they do the coding. Developers do the coding of the software. Whatever application that you are developing, developer do the coding of the software. Your QA engineer do the coding for developing the test cases, or developing the quality assurance programs they will develop, and the operation engineer develop the infrastructure where you want to run the softwares, and some deployment strategies that you want to implement, or some kind of monitoring that you want to do. So whatever infrastructure development that needs to be done, the developers are doing, and they all should be doing some kind of coding, right? They all should be doing some kind of coding, maybe not complicated code as developers, but these guys should also be doing coding. Write things inside a file and put them inside the Git. Then some tools inside your company can read the data from the Git and act accordingly, right? Probably you have your Jenkins server in your company. Assume inside your company you have some kind of Jenkins server, and this Jenkins server can read the code from the developers, whatever the developer pushed inside the Git repository. This Jenkins server can read that code. Then after reading that code, it can basically build, then create the Docker images and push the Docker images inside a registry, and optionally deploy these Docker images into a Kubernetes cluster. And Jenkins is capable to do. And maybe you have Selenium that you run inside the cloud inside your company, and then this Selenium is a tool that is capable to download this code, whatever your QA engineer have written inside the Git, and then execute all the test whatever is written inside the Git. And then assume there is some other tools that is capable to read whatever operation settings, right? I mean, let's call it ArgoCD or some tool that is capable to check whatever data is coming inside the Git, and then any infrastructure change that happens inside by your operations team. Assume there is a tool that will read that information and continuously deploy your production environment, or whatever infrastructure that you have, continuously change your production infrastructure based on the status that is coming into Git. And this is how the machine should be working. This is what people should be doing. So the responsibility of the engineers in your company should be, they do the development, whether they do the coding, whether they do the testing, or whether they do the infrastructure automation. They should do the coding. They put the code inside a Git repository, and then some machines in your company would be picking that information from Git and do whatever is necessary. So right, that's how it should be. So no, the humans update the decide state. I would rather say decide states of whatever decide state of the software is developed by your developers. Decide state of the QA test cases is developed by your QA engineer. Decide state of your operational activities are defined by the infrastructure. So that's what they do. They define the decide state, and then different machines inside your company will pick the data from inside the Git repository and applying these things into the respective places. So this is the kind of way how uh, you should be working, right? So that's the idea. And yeah, and why ops should be Git based. Then I'll talk about the Poet project to understand the difference between, yeah. So the next thing we are going to talk about, why, I mean, till today most of the companies are not really following the strategy. Very less companies are actually following the strategy, but things are going to change in the coming days. But the question here is that the most of the companies are already using Git, right? Most of the companies are already using a Git repository, Git or Subversion or whatever. I mean, your company would be using some kind of source code management tool. It could be Git or it could be Subversion. It could be Perforce. Many different versioning tools are available. It doesn't really matter what you know. If it's good if you are using Git, because Git has a lot of advanced features, some cool features that keep coming. So Git is actually good, seems like a leader, but it doesn't really matter. You should have a source code management tool, and that most of the company are using. There is no doubt about it. Every company have a source code management tool, Git or SVN or whatever, and the companies are already using it. They use all the developer develop everything in their laptop, and after they completed their development they will push the code into the source code management. This is more like a central storage that would that would take the work done by developer continuously push their code change into this Git repository. That's what they do, and this is something that companies are already doing. This is the way how developers are already working in every company. And then in most of the company in QA also, this is the same process that they follow. The QA engineer develop the test cases, assume they are using Selenium, Cypress, or some tool, and then on using that tool they will develop some script, and those script whatever they are developing, they put those script inside a source code management tool. So there will be more than one QA engineer who is working together, and he is putting the code in here, and that is what QA engineers are already doing. And then the operation team are doing a lot of more complicated work nowadays, right? Because every company has different requirement. Infrastructure you cannot define very easily. Some companies uses Kubernetes in production. Some companies uses different cloud service in production. Some companies are running a bunch of VMs using VMware or some virtualization software, and there are companies who is using traditional infrastructure, the on-premise service inside a data center. So the infrastructure can vary, the provider where you are running can vary, and the operation that you want to do inside these machines can vary. It can depend on how what are the type of software your developers are developing, depending on the technology that they are using. The different operations can vary. How to manage things in production, or how to do the monitoring. So there are a whole bunch of work that a operation team actually do. So it is not technically very feasible for people to adapt this GitOps practices completely because of these challenges. Because of many challenges, some of the DevOps tools does not even offer a script-based approach itself, right? For example, some of the DevOps tools, they have a UI, but they don't provide you an option to write programs and put the programs in somewhere, and then the tool can read it as a program. So there are always restrictions. There are still restrictions. So because of many reasons, the operation team cannot completely implement the GitOps practices nowadays, because sometimes they manage cloud from AWS, and they will definitely do a bunch of manual work. Sometimes they will even directly make some change in production. They want to add more machines in production, they might log in to the cloud account and they will click some button to create more machines in production. Then they want to some monitoring system detected that some of the applications are going down, they might even log into the machine and try to solve it even if it is production. So this kind of problems are still happening, and there is no workaround. I mean, you cannot fix such kind of problem in one day or 1 month or not even 1 year. No, so those things will continue to happen. But always what we have to do is, rather than making any change in operations directly, that can result in a lot of problem. One problem is that it can result in human errors. Maybe a number of production server broke down. It should not be humans who will be fixing those problems, because if you try to directly work on production, a lot of things can go wrong. Maybe by mistake you change some environmental variable, maybe by mistake you can, a lot of human mistakes can occur if you directly work on production, and maybe the problem can actually become more and more complicated if you allow your engineers to work on the machines directly, and that is one problem. And then other problems are, you probably cannot keep track of everything if you are doing work manually. For example, you have your Jenkins server, and Jenkins server has a UI, and from the UI you can do many things. But whatever that you do from the UI, they are not recorded anywhere, right? For example, inside Jenkins, you are writing something. So you write some job in Jenkins saying that whatever code my developers are putting inside the Git, Jenkins should take that code, build it, deploy it into some QA environment. So Jenkins has to do that automatically, and some people uses Jenkins UI to do such kind of things. So in that case, you don't really have that work recorded unless you log into the Jenkins UI and check the Jenkins database. You have no idea what is going on. So my point, what I'm trying to make here is that whatever operation work that you do, maybe building and deploying applications, maybe running a bunch of testing on your production service, maybe on QA server you want to run a bunch of testing. So whatever you do, it should be coded and recorded, and that is a proper way of doing things, right? So you have a complete record just by looking at the code. You can define your infrastructure. All right, look at the file that the operation team have written, and then that has all the information what your company operation need to look like, right? So it can actually, this code whatever the operation teams is writing can actually define your entire operation process, which is cool, which is actually very very cool. Right now, just not get into too much technical depth. I'm just trying to avoid the technical details, so don't worry too much. But the idea is that the operation engineers, or basically everyone in your company, should be using Git to store the desired state. That would actually make things easy for them also. I mean, somebody made a mistake, and you can easily correct that mistake, just by making a code change in Git. Due to some mistake, you passed some wrong environmental variable inside your Kubernetes YAML file. For example, coit backend one want to talk to coit backend two, and an operation engineer, a DevOps engineer, assume a DevOps engineer by mistake he mentioned the data environmental variable equal to coit backend two. He forgot to put a hyphen in between coit and backend two. So that's a mistake. And then some tool automatically picked up that mistake and then made change to your production. So all those coit backend one containers that are running in production is now trying to speak to coit backend two without minus symbol. So it's a mistake, and somebody want to correct it. So what they will do, they will jump in and they will understand, hey, there's a mistake, this is the error we are getting in production. So the problem is that the environmental variable is wrong. So the other person, he has a copy of the code in his laptop, and he will correct it, and then he will push the code back to Git, and immediately whatever fix that he did, it will be taken by the respective tool, and then the fix would reach to your production environment. So working with Git is pretty comfortable and convenient for the people. If you are, especially if you are working as a team, working on Git makes a lot of sense. And especially, not managing those machines yourself is a big, is a big relax for DevOps or operation engineer. That's very important. Avoid the headache of directly managing those different machines, different surveys, different clusters that you may have in production. Directly managing them, it's a big complicated process. So GitOps would not only simplify these things, GitOps would also define your entire infrastructure in the base of code. So just by looking at the code, you can identify your infrastructure. It would also build a proper team culture. Everyone can contribute to defining the desired state in Git. And then even if there's a mistake, there are different tools that are available that can actually easily roll back to the previous state. If there's a mistake, if there's a problem, they can roll back to the previous state without much effort. So GitOps is probably the way how most of the companies are going to work in the future. Right? Today, there are a lot of technical challenges. Like I said, this is not an easy process. There are a lot of technical challenges, but most of the companies started adapting these practices, and most of the company are using ArgoCD today. Right? Most of the company who uses Kubernetes, they are already using Argo CD today, and eventually, it's going to become a standard. Argo CD or some other tools, whatever tool that they are using, eventually the tool is going to take a lot of work from DevOps engineer and do things itself. And while DevOps engineers will focus on defining the desired state uh, using their laptop and then pushing the changes into the Git. All right. So next we will try to understand. I mean, I should not be doing such kind of comparison. Actually, this is not good to do some comparison. When you work in a project, you have no idea what you are going to actually work on, right? So, but I just want to make sure that you, without explaining this in detail, and I could be wrong for most of these things. I could be wrong, partially wrong, but yeah, just this is not exactly what the companies may be doing. Every company has their own way of working. All right. So we already have this project that we have, right, that we have been working on, the Coit front end, Coit backend one, and Coit backend two. And based on that project, I will try to explain what job developers do and what job DevOps engineers do, stuff like that. So let's talk about that. Okay, before that, take a short break. Take a 5 minutes break. Actually, I need 5 minutes. I will continue after 5 minutes. Take a short break for now. Okay, so let's continue. Okay, so let's take the example of our project, the simple microservice project, where we have mainly three microservices. We have Quite backend one, that is a independent service developed by my developers. And it is my developers, of course, they will go to the SRC folder and they will do whatever code that they need to do to implement the new features inside the software application, maybe change the color of the website, or maybe change the way how the processing works inside the code backend too. So there may be different kind of feature enhancement that every company might want to do on their application. So developer, what they do is they will come to the respective SRC folder, right, wherever they have written the code, and they will start making the code changes as needed. And sometimes a developer would also write some test cases also, and all those things would be there inside different source code holidays, right? So in our case, we have three microservices, three different applications, and all of them are developed using different technology, JavaScript, Python, and maybe different developers are working on this project. There are three different teams. One team is working on one microservice, other team is working on other one, and other. So it is possible nowadays. Many companies are doing such kind of things. Rather than developing one single monolithic software, they will create some autonomous team and autonomous softwares, and individual softwares can be worked on by individual teams. At the end, all these softwares will run in production, run inside Kubernetes, for example. They will talk to each other using the service IP or service name. They can communicate, they can send data to each other. Code backend one want to send some data to Code backend 2, or Code backend 2 want to send some data back. It's all possible. But the development, when the developer develop them, they will develop them independently, and by avoiding the direct relationship between two software as much as possible. And then these are the folders that your developers are working on, and obviously the resource manifest, it contains your production configuration. So resource manifest, in other words, all these files indicate the state of your application in production, right? A company who is using Kubernetes, and they are using Kubernetes in production, and then how you want to run the application in production is what you define inside this YAML file. You agree with me? The code front end, you want to define it, it as a load balancer, so it will get a public IP. For code front end, what port number it should listen on, and which port it will send the request to, and then what are the ports this service should be speaking with. And then, so like that, how many replicas that you want to run for a given application, and what is the Docker image that you want to use to run the containers, right? A lot of information, and all those informations are recorded as code inside a YAML file. You agree with me? So this is, actually kind of the way how operation engineer should be working, or a DevOps engineer should be working. He will basically write the code, how the infrastructure need to look like, or how these softwares, the code backend 1, code backend 2, and code frontend, how they should run in production. It is defined as code inside these YAML files, what you see inside the resource manifest folder. So today, a project folder would consist of the source code that you can find, the developers develop them, and then also the infrastructure code, how these softwares will run in production is what you define inside the infrastructure code, and it is defined pretty well. So yes, this is the folder that DevOps engineer would be working on. And this is not the only work that a DevOps engineer do. There are many other things. You want to define some monitoring systems. These applications, you are running three containers for code frontend, and who will monitor these containers? I mean, if there is any problem if there is a technical problem, if there is a failure, how you will get to know. So you have to set up some monitoring systems, and for that also you will write YAML files or some code, some kind of code where you will mention I want code front end to be monitored every few minutes, and if there is a downtime, I want to alert this email ID. So all those things, even the monitoring that you are writing, you will write as code. Or sometimes you want to make some write some CI/CD practices. Your company, after the developer added the code in the Git repository, then there are certain processes this code need to undergo. You want to take the code from the Git, you want to build it, you want to test it, you want to deploy them, create Docker images, run them in Kubernetes, then run some test that is brought by your QA engineers. Then using Selenium or some automation tool, you want to run some test. A test script is also there inside the Git. So you want to write some pipelines. In every company there would be pipelines that you will be writing in order to achieve some kind of a quality assurance of your applications. Most of the reason you write pipeline for that purpose. Every time developer make the code modification, this code need to undergo a series of process, right? Building, deployment, testing, again testing, different type of testing, security scanning and stuff like that. So those things also need to be defined as code. What are the things a code will undergo once a developer modified it? You will write scripts, you will write programs like this, maybe in YAML file or maybe in some other format. You should be writing such kind of things. Pipelines as script, monitoring as script, deployment, these are different deployment settings, deployments as script. So everything you will write as script, and then you will put them in the Git repository. And this is what a DevOps engineer do. While developer do the coding of these applications, a DevOps engineer would do the coding for everything else. It could be CI/CD pipelines, it could be monitoring, it could be deployment, it could be some progressive delivery, it could be whatever things that you do, config management, whatever it is, you will be doing the coding. It could be YAML file. I mean, it's not real code, right? YAML file is not a program like Python. It's not. It's pretty straightforward than that. But what it doesn't matter. We will call them code. Actually, it is called code. The point is that it should be files where you will be writing the instructions. That's the important part. Right? So this is a simple project, so it contains only very simple things such as deployment, service, etc. There can be pipelines, monitoring, lot of things. So that should also be written as code by you, by a DevOps engineer. Great. So is it making sense? I mean, whatever I know, I mean, I'm not explaining anything technical. I'm just talking a lot. But is this making sense?
Yes, Basil. Just having one query. Actually, I'm not able to identify where the ArgoCD, ArgoCD will rely in the pipeline, like where it will fit.
Yeah,
So
we
Git will
have
be
to.
there or not?
Yeah, and that
So
I will get into. That I will
okay,
get into next. Yes.
okay.
So in order to implement the GitOps practices of what you should do, that is what we have been discussing so far. And so yeah, how GitOps will be implemented is what we will talk next. Anyone, any questions? Just put your comments in the chat.
What are the like equivalent products with Argo, Basil?
There is a FluxCD. There are many tools actually. ArgoCD and FluxCD are the most they are the best. Other tools are
Okay.
fail to meet certain things. The best, there are only two major players in this, ArgoCD and FluxCD.
Okay.
And there is something called Fleet from Ranger that is also most probably that will also become one potential good software.
So all
For
these are
now,
mainly into GitOps implementations, is it?
yeah, and they insist you to use Kubernetes. So there is no single GitOps tool that you can apply in a traditional environment. So if you are using Kubernetes, then yeah, these are the GitOps tools.
Okay.
Okay, so let's talk about uh, GitOps and ArgoCD. Yeah. So we have established, and now you forget about developers and QA engineers. Let's talk about the DevOps engineer. Let's talk about you. You are going to work as a DevOps engineer in a company. So this is what, assume this is what you will be doing. This is what you will be doing. You will be doing such kind of coding. You will be writing the deployment YAML files, service YAML files, some monitoring settings, and different settings, right? As CI/CD pipelines, everything you will write as code and put those inside a Git repository. And then how these changes what you are making will be applied to your production. When I say production, most of the time I mean a Kubernetes cluster. Okay, the environment that you are running for your customers, that is the production environment. And uh, I'm actually what I have in mind when I say production, I'm talking about a Kubernetes cluster that is running your applications in production. Okay, so that is serving your customers directly. Your customers who try to use your software, they are connecting to this Kubernetes cluster. All those applications what you deploy are customer facing. Customer can talk to these applications whatever you deployed inside this Kubernetes cluster. So inside every company, the company will have a production environment where they will run the software, and customer would be connecting to that software directly using their browser or whatever method that you provided them to. So in your company, you have a cluster in production, one or multiple clusters in production, and that is where all this work should go at the end. Right, nowadays everything can be put inside Kubernetes. Monitoring you can put inside Kubernetes. Then your CI/CD pipelines can also be put inside Kubernetes actually. And deployment, your application, all the containers, all these things you can put inside Kubernetes. Nowadays almost every workflow can be put inside Kubernetes. So what ArgoCD does is, ArgoCD will keep watching your Git repository. Assume this is inside your Git repository. ArgoCD will keep watching the Git repository, and for any code change that you are making, and anybody who make any code change in the Git repository, maybe you change the deployment.yaml file, maybe you added a new environmental variable, or maybe you change the version of the Docker image that you use to deploy your containers. So whatever change that you make, assume a DevOps engineer made some change. Previously the code front end was using V11, and a DevOps engineer changed that to V12, and then updated the YAML file, the deployment YAML file, and put that inside a Git repository. What ArgoCD does is, it will take that change from the Git repository automatically, because you have already synced them. The ArgoCD and Git are in sync always, and it keeps checking the Git repository. And if there is a change that you made to the Git repository, it would apply those changes to the Kubernetes cluster. So using kubectl apply command, or whatever methodology that you normally use to manage Kubernetes, ArgoCD will internally use those tools and resources to apply whatever manifest you define here into this Kubernetes cluster. So this is what ArgoCD do. So every time you want to make any change in any of your system that you run inside production, mostly most of the companies are using for deployments, running your code, running your quite different application containers, different containers, different deployment, different services you want to create inside the Kubernetes, and they all are result of a YAML file, and those YAML files are put inside the Git and modified in Git, and ArgoCD will pick them up and automatically apply those changes to a Kubernetes cluster. And it can also maintain the revision of all the changes that it is making, so that anytime you want to roll back, ArgoCD allows you to roll back to the previous state. That is also a different possibilities that we will explain what is ArgoCD and stuff like that. So this is what you can do.
Basil, I have one question.
Yes.
How can configure this in multi-cluster environment and multi-branching strategies? This
uh,
ArgoCD.
Argo CD may be in sync with more than one GitHub repo, and Argo CD may be in sync with more than one cluster. So you can add a number of clusters into Argo CD, and you can add a number of Git repositories into Argo CD, and then you can when you deploy application in Argo CD, you will specify for this application where is the manifest, which folder in this Git repo contain the manifest, and which repo contains the manifest, and which cluster you should deploy. So those things you can define inside Argo CD.
Okay, so this is like a agent running on the cluster, right?
Yeah, yeah, something like that. Okay, so that is the idea. That is the basic idea how, and another thing. Okay, where you will use Argo CD, that I will explain, even though. Uh, yeah. So your company may already have some existing CI/CD pipelines, right? Most of the company already have some existing CI/CD pipeline that deals with a developer making some code change, putting the code change in the Git repository. Maybe even before they put the code change in the Git repository, some continuous integration process need to happen. So you have a team of developers. You have a team of developers who will be continuously developing the code and putting the code inside the Git repository. And every company now have kind of an automated process that you follow. You will take the code from Git, then you will build the code, and before at the time of building you will also run some unit testing and stuff like that, and then you would also generate some report, and the reports also will be validated and verified, which one failed and which one succeeded. All these things need to happen, and then you will create the executable file, and then this executable file need to be converted into a Docker image. You want to build Docker images and create Docker images, and then optionally you want to put those Docker images inside a registry, and then you want to run some, try to execute the container, check if the containers are getting created from it, do some small level deployment and run some testing. Probably your QA engineer may have developed some test cases, and then you have to do some kind of testing using Selenium or whatever, right? And then you want to do this. So there will be a lot of work that your company has to do to verify the code that your developer have developed, and some report verifications and email notifications to the people who need to get them. So there will be a lot of things that you will do, and finally you want to deliver. You got a proper code at the end, a verified code you got at the end. Now it is time to push this code into production. And in your company, you have different production clusters, and into different clusters, you want to deploy these applications. And these are the different things that inside a company you will be doing. So where Argo CD will fit in this? And first of all, by the name indicate, even though we call it Argo CD, you should not think of it as a continuous integration. ArgoCD is not used for continuous integration. You will be using Jenkins for continuous integration. Jenkins can automate this whole pipeline process of taking the code, building, testing, doing whatever it want to do, and then finally making things ready, making the application ready to be deployed into production. ArgoCD is not the right tool, but let's say you want to do some deployment. For example, you want to deploy your development environment as part of your pipeline. Here you can use ArgoCD. Then you made your Docker images right and straight, and then now you want to deploy your applications into various clusters that your company have. Then you can use ArgoCD. So ArgoCD is not really a continuous delivery tool, as the name indicate. Yes, it is a delivery, it's a deployment tool. It can be used for deployment, and it can be used for GitOps practices. Yeah, but the name is a bit confusing. ArgoCD is not a continuous integration tool. You still need Jenkins, Argo workflows, or whatever tool that your company uses for continuous integration. ArgoCD can take care of some of those jobs, right? So this tool Jenkins can push that manifest into the GitHub to do the deployment. So let's say Jenkins want to deploy one of the development cluster. Your company has a development cluster. One of this cluster is used for a development purpose, testing purpose, and Jenkins want to deploy this cluster. So what Jenkins can do in this case, Jenkins is running all these things one by one. What Jenkins can do at this stage is that Jenkins can push the manifest into Git. Then ArgoCD will deploy the development cluster. Right. So ArgoCD cannot be used for continuous integration. It is rather a deployment tool or GitOps tool, not a continuous integration, continuous delivery tool. All right. So next we'll go ahead and install ArgoCD. So what that also means, we will not be talking a lot in this training about the continuous integration process. That we will be discussing in a different training. So this training is not about continuous integration. Just for your information, we have the built-in Docker images. We created the Docker images and stuff like that. Now it is time to deploy them into your Kubernetes cluster. How you should be doing such deployment or changes in the production, how you should be doing, that's what we will be discussing, right, throughout this training. So this training is not continuous integration training. All right, so the next thing what we are going to do is we are going to install ArgoCD. And in order to create ArgoCD, first of all, you need a Kubernetes cluster. You need a lab environment, you need a Kubernetes cluster, and into the Kubernetes cluster, we are going to install ArgoCD. So first of all, let me set up the lab environment, right? Or create a Kubernetes cluster. And I will be using a cluster in the GCP, Google Cloud, not K3D. K3D is also fine. I can use a cluster in K3D. Most of the work K3D will do, but you cannot have a public IP using K3D. So there are problems in certain areas. So today, what I'm going to do is as we need a Kubernetes cluster for the learning, that's only requirement. So yeah. So I'll talk about the requirements. So in order to, for this training, what you need your laptop, of course. You need your laptop, and inside your laptop, you would be installing some client softwares, some command line tools. Apart from kubectl, you would also use some ArgoCD command line. So you need your laptop, and that is where kubectl will be there, ArgoCD will be there, and we won't be using kubectl. That's the idea of ArgoCD. Let's not use kubectl to manage your cluster anymore, right? Let's use GitOps or ArgoCD to manage the cluster. So, but something can be done from the command line, even though we won't be recommending as a best practice. In order to set up the lab, you need a command line tool, ArgoCD, and you also need kubectl or whatever, and then you need a Kubernetes cluster. And this Kubernetes cluster we are going to create in the Google Cloud, GCP. So we'll create a cluster now, and then we will configure the kubectl to speak to the cluster, and this is what we will do. And Argo CD can actually load those cluster certificate from the kubectl configuration. So that's all possible. So I will create a Kubernetes cluster in the GCP, and then I will install Argo CD inside the cluster. Argo CD should run inside the cluster, and a Argo CD command line should run in your laptop. This is how it should be. So that's what I'm going to do. So let's get started with the cluster creation. You need a cluster to do the lab. So I go to the GCP. You can create a GCP account by you can log in to GCP console.cloud.google.com using your Gmail ID, and they will ask you to verify your card information. It's important that you verify your card information, and then they will provide you a $300 credit, which you may use for doing things. So in my case, I'm going to log into my Google account using my existing Google account username and password. And once you logged into Google Cloud, they will ask you to create a project. When you log in first time, they will ask you to create a project, and they will ask you to, after creating the project, they will ask you to verify your card information. There's a wizard, basic wizard that you need to follow. And yeah, so in my case, I already completed that, and now I am capable to create a Kubernetes cluster in my account. That's what I'm doing inside the Google Cloud. I'm going to create a Kubernetes cluster. And Google Cloud is always, ahead when it comes to Kubernetes. It can create clusters in 2 minutes. I have never seen any other provider creating Kubernetes cluster and managing them so easily. And yeah, but they are doing very, very well. So I'm going to create a cluster, and I will show you how to do that. You have to click the button create cluster on the top in the clusters page. First, you come to the Kubernetes engine. In the clusters page, click on the create button, and then GKE standard. This is what I want, GKE standard. And then I can specify how many worker node do I need inside this cluster. I can specify such kind of details. I can call it some name, call it any name, GitOps, something like that. I'm going to call it GitOps, and leave the options as they are. I mean, no need to change anything here. And on the left side, click on default pool. Here you can specify how many worker nodes do you need in the cluster, and generally 3 is a recommended number. I am putting only 1. That would save some of my credit, some of my money. So that's why I am putting number of 1. So minimum it should be 2. In your case, you can put 3 because $300 is a lot of money. I don't think you will be charged. So you can put a more number of nodes, and then and you can even enable auto scaling, automatically add more machines if needed. You can do such kind of things. And then if you click on the nodes on the left side over here, you can specify the size of the machine. So in my case, it is E2 media machine that I am using to create this cluster. The worker nodes I'm talking about, 2 CPUs and 4 GB RAM. And then the disk size, I'm going to put some 40 GB. I don't need 100 GB. And not much other changes. You can, remaining changes you can keep as it is. Just click the create button, and that's it. Now a cluster is being created inside your G-Cloud account. And now I'm going to connect to this cluster. I have some other cluster that I am deleting. I have some other cluster in my cloud account. I'm deleting. I'm not using this. So now the cluster that you have created takes some time, maybe a couple of minutes for the cluster to become ready. And once the cluster become ready, I can connect to the cluster using the gcloud command line. And that's what I'm going to do. I'm going to, in my laptop, I have already configured the gcloud command line. And I forgot the command to download the config file. There's a gcloud command that I can run in order to generate the config. So I have already created a course in the portal. I would be sharing with all of you, and that contains the detailed instructions on how to create a Kubernetes cluster in the Google Cloud and how we can talk to it using the kubectl command line. So this is the course, Kubernetes Labs. I would be sharing this course with you all. And then I already have created the instructions on how to create the K3D cluster and how to create a Kubernetes cluster. I'm going to share this with all of you. Okay. Yeah, in my case, I already have certain things that already set up in my laptop. I can just execute this command, replacing this. Name of the cluster is GitOps. So this is the command I will run on my laptop. Yeah, this is the command I will run on my laptop to configure my kubectl to talk to the new cluster, right? Okay, great. So I am done. I am done with the changes. So what I did is I have created a cluster in the GCP and connected used kubectl to configure kubectl to talk to the cluster. So I have done this. I mean, this is what you have to do. A detailed instructions is available at the portal, so you can simply follow that particular portal, and that has all the instructions on how you can set up the lab environment, how to set up the cluster in the Google Cloud. Okay, great. So now you have the lab environment ready. The next thing what we are going to do is we are going to install ArgoCD. We are going to install ArgoCD inside the cluster. So right now this is the situation. I have kubectl configured to speak to the cluster. I have a cluster called GitOps that I have created in the GCP, and throughout this training I'm going to work on this particular cluster. And there are two things that I need to do. I should install two software. The first one, I should install the server component. The ArgoCD server should be installed on the Kubernetes cluster. And the second thing, I should install some command line, ArgoCD command line to be installed on my laptop. And then I can execute the ArgoCD command to create different applications inside the cluster. So there are two software, ArgoCD to be installed on the server and ArgoCD command line software to be installed on the laptop, whichever laptop that you're using. So let us start with the first step, install the ArgoCD server. So I go to the browser, install ArgoCD, simply search in Google, install ArgoCD, and then you would be taken to the ArgoCD documentation page where you can see the installation instruction for ArgoCD. So it is basically, first you will create a namespace. A namespace is a virtually isolated place in Kubernetes cluster. If you have a Kubernetes cluster and if you are creating a namespace, it actually means you are dividing the cluster virtually to create some kind of isolated space. So you can install Argo CD in its own dedicated namespace without affecting other application. That is possible. So a Kubernetes cluster can be split into multiple namespaces. So in my case, no, I'm going to create a separate namespace called Argo CD, and inside that namespace, I'm going to install all the software, Argo CD softwares. So what are the instructions? First of all, create the namespace, and then there is already a YAML file that I can execute using kubectl apply that will take care of all these installations inside the cluster. So this is nice, right? Every time you want to install a software in Kubernetes, we will be using kubectl apply. It could be your software that you are going to deploy inside the Kubernetes cluster, or it could be a software like Argo CD or something, or Jenkins or whatever, something that you want to install. You will get some existing YAML file from the respective provider. This is the YAML file that the Argo CD guys have already prepared for you, and it contains deployment YAMLs, service YAMLs, some other resources, some permission YAML files, and all those things they put together inside one single file. And your job is to just execute this command kubectl apply against this particular file. The file is available at this URL, and different Argo CD. There are a number of CRD, which you don't have to worry too much at this point of time. And then there would be different deployment, the different services that need to get created, and they all get created, and the instructions are already put inside the YAML file like this. The service account for some permission, it creates service account, and then it create different some roles. This is also something related to the permissions inside the Kubernetes cluster. And then you want to create some config map, some deployment, some services, right? All these things. This is a service that you are creating, different services. One service for metrics application, and other service for some Redis application, different services and different deployments it will create. So after just executing this YAML file in the cluster, Argo CD will be up and running. It's as simple as that. So when you run the kubectl apply command, rather than specifying the YAML file, you can also put a URL, and that's what we are going to do. I already have the URL that I got from Argo CD documentation. So the first thing, I will create a namespace by running this command. So let me confirm I am working on the right cluster by running the command kubectl config get context. I should be, as soon as I executed the gcloud command to generate the certificate, I would be already working on the right cluster, which I am, right? You can see GitOps is the cluster, and currently I am working on that cluster. Great. And now we can start running the kubectl command, kubectl get ports. You can see all the ports that are currently running in the cluster. There is nothing as expected. There is no cluster currently running on the remote cluster. And now what I'm going to do is I'm going to create a namespace inside the cluster by running this command. The command is kubectl create namespace. Namespace is a virtual space, a isolated space that you can create inside Kubernetes, and in that space you can do all the installation. So that's why I'm creating a namespace with the name Argo CD. This is the kubectl command. If you run this command, then kubectl will create a namespace inside your Google Cloud cluster, the GitOps cluster that you have just created. And now I want to install something into the Kubernetes cluster. And generally, I always use the kubectl apply command to do all the installation. And today, I'm not here to install Quite frontend or Quite backend or any of my application. I'm going to install something else. I'm going to install Argo CD inside the cluster. So, and these YAML files are not managed by me. I already got this YAML file to install the Argo CD from the internet, and this is that YAML file. And then, yes, I should mention, so we created a namespace called Argo CD, and when you run the kubectl apply, make sure that you apply Argo CD into that namespace using this option. So let's do that. Go back to your terminal, kubectl apply -f In between, I put -n ArgoCD. This is the namespace that I created in the previous step. And then -f, then you provide the URL, the YAML file, which I already copied from this documentation page. And this ArgoCD people have already prepared this and put that inside a URL. So for me, I can simply run the kubectl apply command and it will take care of all the installation. So just run this command and you will see a whole bunch of lots of resources, not only deployment and services. It is creating some custom resource definition. Right now, you don't know many of these things, so don't worry too much. A service account is getting created, number of service accounts are getting created, number of roles are getting created to decide what are the permissions to be set. A number of configurations are getting created, some secrets are getting created, and then a number of services and deployments are getting created. These are the actual workload services and deployments. A number of services and deployment and stateful sets are getting created, and some network policies also are getting created. So a lot of things got created inside the Kubernetes cluster. It's not only one resource that you created, it's many, right? And I think I might have already shown you that YAML file. There are many resources, and all the resources are getting created one by one onto the clusters, and that's what I did. I have successfully installed um, ArgoCD into the remote cluster, and it's done. And now you can confirm the status by running the command kubectl get ports. You already know this command kubectl get ports, and when you run this command, it would show you all the ports that are currently running inside the cluster. And I should use this option -n ArgoCD if I want to see all the ports that are running in this namespace. By default, it won't print you the ports in the ArgoCD namespace. If your intention is to see the list of ports in this namespace, you should use this option alone. So basically, I would see a number of ports running, not only one, many ports I will see running. ArgoCD consists of more than one software running across different ports. So don't be confused if you see more than one ports running. Actually, there are total 5 ports running, and ArgoCD is developed as a combination of a number of software, and that's why you see many ports running. And all these ports are running different software. There is a application controller that has some responsibility. Then ArgoCD server, that is the actual server component that run inside the API server. Then there is some repo server that is responsible for talking to GitHub. Then some Redis is responsible for storing some temporary cache. Dex server, Dex server has a different responsibility altogether. So there are different softwares that started running inside your Kubernetes cluster after I executed the ArgoCD install command. So number of I will talk about the ArgoCD architecture sometime later, but right now, when you install ArgoCD, actually a number of software, a number of ports will start running. ArgoCD is developed as a software that consists of different software components. Each of them run in different ports. Okay, so you have installed ArgoCD on the cluster. Now you have to install some command line tools in your laptop, and that is what we will do next. You have to install some command line tool in your laptops. Okay. So this is what we did in the GCP cluster. We install ArgoCD using kubectl, and next we are going to install ArgoCD CLI in your laptop, right? In your laptop, from wherever you plan to manage your application, right? Most probably a developer laptop. So, but we won't be using this command line a lot in the actual GitOps process, right? The main intention of GitOps process is to avoid command line usage. I hope you understood that by now. whenever I was explaining about GitOps, you always put something in Git and some machines will take the code from Git and apply to various systems in your company. That's what I said. So don't use command line. The first and most important thing you should remember, don't use command lines to manage your applications, not kubectl. So we want to get rid of kubectl. So why we are installing ArgoCD CLI? That is just for learning it. It make things convenient. A DevOps engineer must have some command line in their laptop. It does not really mean that I'm going to use this command line in my actual GitOps process of the company. But this command line I will be using for creating different applications in the cluster, stuff like that. So yeah, so let's install ArgoCD CLI. So I'm going to install the ArgoCD command line tool in my laptop, right? So you can simply search in Google, install ArgoCD CLI command line, and then go to the respective documentation of the ArgoCD. And over here you would be able to find this is for installing on the server. Come down further, and yeah, the next step is to install it on your laptop. And yeah, if you are using Homebrew, which you are most likely not using, if you are not using Mac, so in that case you can actually go to this URL, download the ArgoCD CLI for your respective operating system. If you are using Windows, download this file. If you are using MacBook, you can either run brew install command, or you can download this file, or in Linux you can download this file. So this is the command line, and after downloading this file, better you copy this file to your system binary, for example user bin, or or maybe define a path. Otherwise, after downloading, you have to execute the command from the folder where you downloaded it. So instead of doing that, after downloading this file, you will copy the file into the respective path. So if you are using Homebrew, then you can simply run this command on your laptop's command line. Then automatically it will start installing ArgoCD from some repository. And in my case, this command line should be already installed. So yeah, this is a single command that will automate the ArgoCD CLI installation on my MacBook. And yeah, and if you are using Windows, maybe what you will do is you will download this file. You will download this file, the exe file, and this is a direct executable file. I mean, you don't have to do any installation. This is a directly executable file. The problem is that in order to execute the file, you have to go to your command line, right? Assume after downloading this file, you have to go to that folder wherever you downloaded it. You will, yeah, in my case, it is already installed. In your case, assume you are using Windows and you downloaded, you go to the Windows command line, git bash or something, then you have to go to the folder where you downloaded it, and then you have to type the command dot slash. In Windows, it's dot backslash followed by whatever file that you downloaded. So in your case, the file name is going to be something like, if you are using Windows, this is the file by default. And yes, of course, if you want to rename the file to ArgoCD, better rename this file to ArgoCD, because I would be using command as ArgoCD. Better you do the same thing. And in Windows, if you can also, rather than putting this file in the downloads folder, you can define a path in your Windows environmental variable settings. You can add, put this file inside a folder and rename it to ArgoCD. Better use the command ArgoCD. I will be using that command, and include that into your system path in your Windows settings. Just search in Google how to set path in Windows. And this binary should be, whatever you downloaded should be inside the path, so that you can execute the command without using a dot slash. You can run the command from anywhere in the command line. So install this command line tool, If you are using MacBook, you can run Brew install, or if you are using Ubuntu, I think it supports apt-get also. And in Windows, download the binary and put that in a folder and include the folder inside your system path. All right, so that is how you install ArgoCD. Great. So tomorrow we will talk about we will create some applications. We'll configure ArgoCD to talk to GitHub, configure ArgoCD to talk to your cluster, right? ArgoCD want to synchronize whatever data coming to Git. ArgoCD want to take it. Then these settings ArgoCD want to apply to some Kubernetes cluster. So ArgoCD may be talking to some Git repositories, one or more Git repositories, and ArgoCD may be talking to one or more Kubernetes clusters and synchronizing them. That's what ArgoCD do. It continuously 24 by 7, right? 365 days. That's what ArgoCD do inside your company. It keep checking the Git status and synchronize those status into your Kubernetes clusters. So we will see how ArgoCD will talk to Git and different Kubernetes clusters and how it will do the synchronization and stuff like that. So that's what we will talk tomorrow. Yeah, and I have some questions in the chat. ArgoCD is compatible with Kubernetes only? Yes, yes. So GitOps is not an easy implementation in the environments other than Kubernetes. So ArgoCD and FlexCD, both of them work with Kubernetes, and there is no support for the traditional environment. In traditional environment, achieving such kind of things is very, very difficult. Literally, it's kind of a huge process, because in a traditional environment, people directly log into server, work on the server. People directly they even log into production surveys. I mean, it happens in real time in a traditional environment. So it is very difficult to achieve a proper GitOps practice. There are many companies, maybe the giant companies have achieved it, but not every company. It's not very easy to implement GitOps practices, whatever practices that I discussed today. It is extremely easy to implement them in a traditional environment where you are using Jenkins for CI/CD and some Rundeck or some scripts or Ansible for deployment. So those are the tools that you're actually using. Achieving GitOps can be a bit difficult. It can be achieved, but difficult. That's all. So ArgoCD work only with Kubernetes. FlexCD is also work only with Kubernetes. And yeah, I will be sharing one course with you that contains the instructions for this. Is the course, and I would be adding few more topics regularly into this course. Actually, for now, it contains how to set up your lab environment, how to create K3D cluster locally, how to create, as understand that few of you will have trouble. So follow this documentation if you have any trouble creating the Kubernetes cluster, either in the GCP or in K3D. And then demo project, go through this project also. So I will try to add more data inside this course, so you can keep opening this course to see if something new has there. Learn it. Now whatever I would be adding in this course would be important topics. So just keep practicing them. Okay. Right. So I'll share this course with everyone today. We can use GitLab pipelines itself for CI. Yes, yes. And we need additional tools like Jenkins. Yeah, GitLab pipelines is good enough to implement pipelines in most of the cases. Yes, and it can vary from case to case, but yes, many people uses GitLab pipelines alone for running all their pipeline requirements. So people does that. But Jenkins is, I mean, multifunctional, right? There are very less company who survive without Jenkins. Maybe most of the things GitLab pipelines is capable to do, but certain things it's extremely difficult. Jenkins is already an established a big ecosystem, and there is nothing that you cannot do with Jenkins, right? Almost anything in the world, anything that any project need, Jenkins have a solution. So at some point you might need to create some pipelines in Jenkins. So I don't know, depends on use case. Can we download the courses videos? Somali, they are in Google Drive. You can try. Why not? So, I don't have any problem. And anyway, actually, I am whatever courses that we are conducting, I'm just recording them, and I am asking my video editor person to build them into some good course. So even after the training, you will get an option to renew the video access at a very, very cheap price. So probably downloading videos are not necessary, but I am not against it. You will I would be providing a better option to you after we completed the training, and you will have 1 month access to the videos even after we completed the training. So for 1 month it's not a problem. After 1 month, if you still need it, there would be alternate solutions that I would be providing, better solutions actually. Yeah. After creating a multi-node cluster using K3D, getting HT error and how to resolve that. Oh, okay. I did not realize that HT. So what is the command you used, Kiran, for creating the cluster? It is just minus minus surveys 3 and minus same command what I used. Kiran, send me the command.
Yes, yes, Basil. After creating the cluster, like same command I have used for creating cluster, and after I create cluster, trying to execute that kubectl will get nodes and other commands. When I try to execute, it is showing as some leader change and HCD request timeout, and all those errors are coming. API server not
Maybe the reason is that reduce the number of surveys. Maybe you don't have enough capacity in your laptop to run those many surveys and agents. Try to reduce, run only one server and one agent using K3D. Minus minus surveys one, minus minus agents one using K3D. Most probably that will solve the problem. I think that is the problem. Generally, K3D has the solution for the API server load balancing and HT, whatever error that you mentioned. K3D already have solution. If you are facing the error, the chances are that some surveys are crashing because of CPU and memory limits. So reduce the number of surveys. Last week we used Helm for deploying
thanks.
application on the services. Vinay, so Helm, Customize, or those tools will make the manifest management easier, and they are completely different than GitOps. So Helm or Customize, what they do is they will package your entire applications so that you don't really have to directly deal with these manifest, all these YAML files. So that headache can be avoided if you are using Helm or Customize. And GitOps, basically, GitOps can either take the YAML files, or it can take the Helm manifest, or it can take Customize, or whatever way you wrote your infrastructure. It could be in Helm, it could be in Customize, it could be in plain YAML files, whatever it is. ArgoCD can pick them and deploy them to the cluster. Yeah. How to create Docker login account? You can share me the URL. So it's hub.docker.com. So anybody, if you're trying to get a Docker ID, go to the website hub.docker.com and register yourself. You have to provide a username and password. and the same credentials you will use with your Docker login command. Okay, anyone else, any questions? Is Jenkins and Ansible course added? Ansible course, no, they are not added. But they will be part of it. Hopefully it will take another month, but they are under, they're being, Ansible is already being built. Jenkins may take a little more time. Okay. Yeah, thanks guys. So we'll continue tomorrow. We will start with ArgoCD applications tomorrow.
Yeah, thanks.
Bye bye. Thank you.
Thanks, Vasil.
Thank you. Bye bye.